All right, so that's good. So let me just double check, make sure the recorder is also recording the audio, and it is recording the audio. That's great. So what we'll do today is to continue what we did last time, and because the recording did not go very well last time because I was fiddling with the screen resolution, when I changed the screen resolution, it broke the recorder software, and I did not realize, and that's why there was no recording on Monday. But now that we are back from a day off, it's getting better, and I think we can do this whole recording here. So what I'll do is I'm going back to AI2 first, and I think I'm using the Dr. Tech 2014 fall account, so I'll start with that one. But the important stuff is already captured in a text file, so I'm kind of glad that I used a text file to remember everything that is actually important, because we were in the process of developing an application, and I was just kind of showing you guys the process of doing it. So here is the text document that we were working on the other day. Basically, I wanted to create an application so that the people who shoot airgun field target matches do not need to handle like pieces of paper that easily flies away, and difficult to keep track of. Yep.
Did you post the what we worked on?
No, I have not posted yet.
The AIA file?
The AIA file is pretty much empty at this point. It only has the splash screen, which doesn't really have anything useful on it. And screen 2 is almost completely empty. I mean, I just used some random stuff here for layout control and stuff like that. So it really doesn't have anything that useful. So I'm not sure whether you guys still want it or not at this point, because it's not really that useful. Okay. So getting back to the description of the application. So I started off with listing the values of the application. In other words, I started off listing the reasons why people want to download and install this particular application, much like what you guys are doing too with your project. Okay, so because you have to start with that, and you have to end with that as well. In other words, after you're done with your project, after you spend all the time to develop your application, you have to go back to the list of values or the original objectives of your application and double check and see whether your project, your application, is meeting what you thought was the reason why people would download your application. Because if it's not doing that, that means you have to go back and revise the software so that it meets the original objectives of the applications. So that's why this is kind of important. You have to kind of keep an eye on these things as we go, with this application. We talked about use cases. Okay, there's only one actor in this case, which is the competitor, basically the shooter, who needs to keep track of the score. And the use cases include entering log entries, scoring, review log entries, and to be reminded to recharge what we call PCP, or pre-charged pneumatic air guns. Because at a certain point, if the tank pressure drops below a certain point, it will change the velocity of the projectile, and then it won't be accurate anymore. So from the use cases, we derive some of the features. We want to be able to change the number of lanes because that depends on the competition. And this just popped up over the weekend. Not over the weekend, just popped up yesterday. Because there's another match in Concord this coming Sunday, and they have 12 lanes instead of the usual 10 or 15 lanes of the other, competition organizer. So that just really kind of emphasized the importance of being able to change the number of lanes, because it depends on who's organizing it, and also how many lanes they feel like doing on a particular day. We want to be able to delete or edit log entries, so that we can go back and change if we need to. We certainly want to be able to enter or create new log entries, and to review log entries. And we also want to be able to save the log entries into files, because once you can save log entries into files, you can then upload the files to, let's say, Dropbox or some other places or you can send it by email as an attachment to other people. So it becomes easy to share, all of those information, all of that information. So we're still doing okay so far, with all this stuff that we kind of talked about on Monday. Okay. So the next part is to analyze what kind of data are we dealing with here. So we're dealing with, a single log has all of these items, has all of these attributes. It has the name or the ID of a competitor so that we can identify from the log itself, I can identify whose log it is. Okay, I don't want to have to say, okay, I got a log here, but who's the shooter? We have to be able to log the date and the time, okay, the location, and optionally a picture of the location. Okay, that might be useful. Excuse me, that might be useful afterwards. And then we have to, in the log, we have to also be able to log matches, okay, or at least one match per log. But in each match, there will be multiple lanes, can be 10, 12, 15, or for a shorter competition or match, maybe it's only about 7 or 8, okay, because for pistol matches, I know for sure that they have a reduced number. So for pistol matches, they typically have 6 to 7 lanes, which ends up with 28 shots or so. Then for each lane, we have 2 targets, okay? At this point, I'm not quite sure whether to make the number of targets also a variable, because it seems like, with all of the matches, there are only 2 targets per lane, okay? So the question now is, how much trouble do I have to go through to make the number of targets a variable? If it's not too much trouble, might as well do it, okay? If it is too much trouble, yeah, maybe not, okay? I'm thinking, we can make it an internal variable so that in case we need to change it, we can go ahead. But we may not provide the actual configuration screen because that doesn't seem to be a need to do that. And then with each target, there are usually 2 attempts. And once again, this is just the by convention, okay, by the competition rules, of the International Field Target Organization, there are 2 attempts per target. Now, do I want to make it a constant and say just 2, or do I want to make it kind of more flexible? Once again, if it's not too much trouble, I would like to make this a variable as well. Okay, just in case someone is doing this, in a very informal fashion and just want to say, oh, instead of having to move from one lane to another lane all the time, let's make it 4 attempts per target. Then I can just change one configuration and be able to accommodate that. For each attempt, I have a timestamp, when was the log entry itself produced, not when the shot was fired, but when the log entry itself was actually created. The gauged distance, okay, because with field target competition, this is a big deal because this allows the shooter to later on use a actual range finding instrument to find out, okay, this is the exact distance according to my instrument, and this is what I thought was the actual distance. Is there a difference? Well, if there is a difference and it's consistent, maybe the scope is not set up correctly, or maybe your prescription is not set up correctly, and something needs to be done. And the most important part, unfortunately, is the last item here, because the whole purpose of this application is really just to record a hit or a miss. Okay, do I get a point or not? Okay, that's its own purpose. That's the original purpose, is to replace the paper that keeps track of all the hit and misses. But it is here, okay? So it's important that it is finally here. So now we want to talk about the screen layout. The screen layout, needs to do the same thing. So what I did last time was I copied this whole thing here, because all of this stuff needs to be recorded, and I pasted the entire thing over here. And then I used parentheses to indicate what I might want to do for that particular entry in the screen. But I have not even separated all of these items into different screens yet at this point. So that's where we stopped on Monday. So what we'll do today is to actually start to design the screens, implement the logic for individual screens, and start with that. So here is an interesting, this is an interesting point of this project, because we are now transitioning from just planning, doing all the planning in our head, to actually coding. Okay, so we are going to switch to AI2 and be able to actually use AI2 to do not just the screen layout, but also to specify the logic for each of these screens. So how do we proceed at this point? That is the question. Okay, so the biggest limitation is AI2 or App Inventor has no ability to create new things on the fly. So you cannot say, oh, this is a competition with 16 lanes, okay? So create 16 of these things. It has no ability to do anything like that, okay? That is really kind of like a big limitation, but I'm thinking that we can actually, do something about it and be able to, quote unquote, fix that problem. What we'll do is we'll look at the smallest single item and turn that into a screen first. Okay, and then, so in other words, we are building up the hierarchy of data from the ground up, from the bottom up, instead of from top down, which is what most people recommend. This time we're doing it from the ground up. Now, doing things from the ground up or bottom up programming has one huge advantage over top down. It makes testing easy. Okay, because you're building from the ground up, so the first thing that you create has no dependency on anything else. It can be tested all by itself. When that is tested, you build up the next level, but by the time you build up the next level, the ground level, the first level of stuff that you need is already done. So the second level can be tested almost completely, and then you move on to the third level and so on. Okay, so bottom-up implementation has that one advantage. When people talk about top-down and how it is the great way and the perfect way of doing things, they're talking about mostly from the planning perspective. Okay, from the analysis and planning perspective, yes, that would be a great thing to do. Think about how you write an English paper. Okay, once you have planned out the structure of your English paper, how do you get started? Well, you start to jot down ideas, right? Okay, little ideas, and say, oh, I think this might be useful, and I think this belongs to the argument piece. Throw it into the argument bucket, right? And I think this is also, oh, this is a great summary. This is a great quote. I think I'll use it either in the introduction to get the attention of people, or I throw it into the summary so that people remember that as the summary, as the conclusion of my entire, article, and you throw it either into the introduction or the summary section. So you're essentially doing bottom-up work when you're writing the article. It's just that we don't call it, bottom-up in that way. Okay, but we're basically doing the same thing here. It's bottom-up programming. We start with the smallest unit. The smallest unit here is one attempt, because in one attempt, I really do not have any division of all of these items. There's only one timestamp to deal with. There's only one gauged distance to deal with, and there's only one hit or miss to deal with. Okay, so that's one attempt. Let's turn that into a screen first, okay, and deal with the underlying data structure. How are we representing one single attempt? Okay, and you already know the answer, right? Because you know how much I like lists, right? So we're going to use list for this purpose, right? Before we move on, I forgot what I was about to do. That's okay. Probably not important.
It'll come back to it.
Yeah, if it is important, it will pop up again. All right, so I got AI started. And now when you're doing bottom-up programming, the other part that is kind of tricky is how do we deal with the screens? Because we have to create new screens one after another. So when you're dealing with bottom-up programming, there are several ways to do it. One way to do it is to turn the first screen into the screen that you are trying to program, so that way you don't have to switch screens when you are just debugging that particular screen and the logic associated with that screen. I'm not going to do that. Okay, so what I'll do is I'm going to get out of my App Inventor screen here, go back to my projects. We have FT Scorer here, and what I'm going to do is I will re-download this and create a new file. Okay, so let's go to projects. Actually, is it time to do it? I'm getting rid of all of the useless, components in Screen 2 at this point. and I go to blocks and double check, serialized, JSON is still here. Okay, that is one function that I really need to use. We have a global variable to make a list. Oh, this was a failed experiment. I was trying to see if I can make a list of the components, and you tried it out already, and that did not work. I kind of figured it would not work because because otherwise they need a way to transmit that or turn it into a text file, and that's not going to be easy. All right, so there's one more thing we want to do here, because with this screen, which is a blank screen with nothing except for the procedure to serialize a list into a JSON representation, if there are any other subroutines that I want to replicate between the screens, I want to do it here before I replicate this screen itself into multiple copies, right? Sorry? Lower. Like that.
No, I want to see the whole thing. Oh. Thank you.
Okay. So there's one more thing that I want to do, because I want to be able to stay out of the view. So I want to be able to.
Thank you.
So I want to be able to make it easier on myself to create a key pair list. Okay. Now, App Inventor already has some support for it. If you go under list, it has one support for that, and it is under all the way down here. It is lookup in pairs. Okay, so if you look up the documentation on this, it says return the value associated with the key in the list of pairs. Okay, so what this is I'm just going to go back to my text editor here. What this means is you can create a list that has key value pairs. So one key value pair all by itself is a list. I use parentheses to indicate the beginning and the end of a list. So in this case, I can say, let's just say that we are dealing with a single attempt. Okay, so a single attempt is going to have the following list items. The first one is going to be the timestamp. So I can just say the key is timestamp, and then the value is whatever the internal representation is, which is an instance. So we'll just kind of gibberish, put a whole bunch of big numbers here. That's the first item. And then the second item is the gauge to distance. So now when you're dealing with distance or timestamp or anything like that, it is important to remember, at least yourself, what unit you're dealing with. Okay, so you got to remember, what is the unit that you're dealing with. And that can be an option too, because field target is actually very big in Britain, in Germany. So if you want the application to be popular over there, one thing you have to do is to be able to use meters instead of yards. Okay, so that also means whatever you use here may not be the unit that is actually being used. So that you have to be careful. Okay, so there's a question here what I'm going to use here. So I'll just kind of put a number here, not quite decided how to do it. The next one is whether it is a hit or a miss. So I will say this is a hit, miss, hit, and the answer is either yes or no, or true, false. So we can say true, it is a hit. Okay, so if it's a miss, then this particular value, the value of the key hit, is going to be false. Are there any questions at this point? Okay, no questions. So I'm going to make this a single attempt. So one single attempt is a list, and that particular list has 3 key value pairs, and each key value pair itself is a list of 2 items. The key is one, and then the value corresponding to the key is the other one. Is that part okay? All right. Okay, well that's not too bad, okay, but it does raise a question. So whenever I have a question here, I'm going to put the note here and say, how do we deal with distance? Okay, what unit are we talking about here? Timestamp, I'm not as concerned, because when you use the clock component, it has its own internal time representation called an instance. So what we can do is just to store the instance itself, which is going to be a big, huge number, but that's at least consistent internally. And App Inventor 2 already gives us the ability to convert that back into the date and the time that we know of. So we don't have a real issue with that one. This one, definitely not an issue. So either it's a hit or not a hit. Instead of true, false, you can also use a 0 and 1, but I would pick one or the other and make it consistent throughout the application. The 0 and 1 actually makes more sense, so I'm going to switch here and say, this is either a 0 for a miss or a 1 for a hit. Okay, so there we go. All right, so I don't want to proceed anymore until I have determined what kind of distance we are dealing with here. So we want to be able to convert distances pretty much on the fly. In other words, if it is recorded in yards, if I switch in a configuration and say now I want to look at distance in meters, it will convert everything, or at least display everything in meters at that point. Okay, so I want to be able to do something like that. Any ideas how we can do something like that? In other words, what kind of internal units should I use so that I can somewhat easily convert between the British or SI unit. This is really confusing because the British unit is yard, but the British don't use yard. So between the SI unit and the imperial units, which one to use? One way to deal with this, I'm not sure how many of you have a program that has to deal with a unit conversion. Probably not at this stage, but at some point, if you develop applications that are quote-unquote international, that is intended for other countries, you will have to deal with conversions. With distance, it's easy, because what I want to do here is I can now fix the unit to be just internally. It is keeping track of millimeters. Okay. Now, the reason why I keep it at a millimeter level is because I can easily convert, knowing what millimeter is to the actual distance. I can use that and convert it back into yard or meter, either way, with relatively few calculations. Going to meter is easy, right? How many millimeters do we have in 1 meter? 1,000, exactly. Because 1 milli is 1,000th of something. So 1 millimeter is 1,000th of a meter. So there are 1,000 of these things in 1 meter. In yards, it's not too hard either. There are 25.4 millimeters in 1 inch. And then we have 36 inches to 1 yard. So you just do the calculations. It's convertible. I mean, it's okay. We can do that. Okay, so that's not too bad. Okay, so I'm using a fairly small unit to represent distance. So this way I can keep the accuracy and be able to do the conversion either way. Is that okay so far? Yep, go ahead.
You could also initialize the variable in this particular case, like you did in the other program where you create a formula within the variable, right?
Formula within the variable.
You kind of did that with the.
I used the variable in a calculation. That's what I did. Yep. Okay. Now, with all of this stuff here, okay, this is basically the representation of one attempt. Okay, it looks like this. But right away, I know that I need something else because I need to know the configuration of the software, because otherwise I would not know how to convert or how to display the distance. Is that making any sense? Because remember, I'm now concerned with how to do the data entry. How do we enter the data of one particular attempt? So unless somebody wants to do the conversion into millimeter by hand and type in the millimeter number, which is not how most people do things, we have to make it easy for people to use the software, which also means in this particular data entry screen, we need to know the configuration of the software. At least we need to know what type of measuring units we are using for distance. Is that making any sense? So we are going to keep track of that as well. Okay, so now we're saying in terms of configuration, it is also a list of pairs, and one of the items of this list is going to be distance unit. And with distance unit, this part is entirely up to you. If you want to use the words, yard, meter, and so on, that's cool. So in this case, we'll say yard, and as a comment, I'm going to say allow the units of yard and meters, because those two are the most commonly used measuring units for distance, at least in the context of air gun shooting. Are there any questions about this part? All right. Now, I'm keeping track of all of these things using just a text editor, which also means that you don't need anything that is fancy to do all of this stuff here. The key point is not all the fancy formatting, okay, heading, bullet list, and all kinds of stuff like that. The most important part is to write it down. Don't try to keep it here, okay? Don't try to keep it in your mind, because most people cannot keep track of all of this stuff and remember everything from one programming session to the next. So it is important to just write it down, somewhere, and we can sort this out later or reorganize and make it look nice later. Okay, so we have the representation of one attempt. We have some kind of configuration data here, and they're both using key pairs. Now, the important part about using key pair is it has a key to identify what the value is. If you want to, some people don't do it this way. Some people just use a list and use the position of the item to imply what it is. So they would use a list of only 3 items, not 3 pairs, but 3 individual items, and it is understood that the first one is a timestamp, the second one is the distance, which obviously is not the case now because that's going to be a much larger number. So I'm going to put in 3 more zeros to kind of to represent 45 yards. So just to be consistent here, and it is a hit. Now, I personally do not like this representation because when you look at just the TinyDB file itself, you cannot easily tell what it is. That's the problem. Okay. With the other format, when you look at TinyDB, the text file representing TinyDB, it's pretty clear what we're dealing with. Okay, because each value has a key that is descriptive of what the value really is representing. So that's why I like a key pair list instead of just a regular list. Okay, but that part is kind of personal and subjective in a way. And if you want to save space, if space is an issue, this is more compact. But I don't really like it because the position implies what it is, and I don't want to remember which position is representing what. With the first one, you can do something like this, and it wouldn't matter. Okay, because you're looking up items based on the key and not based on the position. So you can reorder things all day long, and it still means the same thing. And that's one thing that I really, really like about the key value pair list. Okay, so having said that, and emphasize the importance of having a key pair instead of a key value pair instead of just a value, let's go ahead and write one subroutine that will help us to deal with this. Now, I mentioned earlier that list, if you go to the list and look down all the blocks, the last one helps us already. It returns the value associated with the key in the list of pairs. So it is useful for looking up something. But when you want to create or modify a list of pairs, this is not going to be useful. Okay, it can, at the most, it can tell you, oh, we don't have that item here. But if you want to add an item, you can do that pretty easily. You just add one more item to a list, which is all by itself a pair. Okay, so adding is not an issue. What about changing it? Remember, we want to be able to modify, all of our log entries, which also means at some point we want to be able to modify the value of a key value pair in a list. And App Inventor has nothing to support that. And I know that's going to be an important feature to me in almost all of the screens. So I will write this procedure here in screen 2, so that I can replicate this to all of the other screens, so I don't have to replicate the procedure later on. This is one huge deficit of AI2 is the lack of the ability to reuse code across the screens. That really is a big bummer of this particular approach. But we can kind of get around that one. Okay, so I'm going to write that procedure, and as I'm writing the procedure, it's kind of a way to kind of show you guys how to start writing a procedure too. So I'll just go ahead and start with the procedure. Now in this case, I can use either one. I can use either just a regular procedure or a procedure that has a result. For those of you who have taken other classes, a procedure that does not have a result is kind of like a void function in C and C++. Okay, it returns a type of void, which means there's no value to return. Whereas the other one does return a particular thing. So when we create a procedure like this, which has the intention of adding or modifying the value of a key in a key value pair list, do you want it to return anything? That is the question. Well, it can potentially return one thing. It can return, whether the item was there or not, right? So it is usually useful to return a piece of information that you can decide later to discard and say, that's not important, than not to have it to begin with. Then you have a problem, right? So let's go ahead and use that assumption and basically make this procedure return a particular value. And we'll name the procedure accordingly, which is to update KV list. Okay, so so this is used to update a key value list or the value of a particular item in the list, like that. It will require some parameters. In other words, we have to give it several things to process. So I'm going to give it a bunch first. I think we'll need about 4 of those things. And rename these things accordingly. The first thing is obvious. We need a list. We need a list of key value pairs because that's the one that we are processing. Okay, so we need to start with that as a list. And then we have to specify a key. In other words, whose value are we attempting to update? Okay, and the new value. Okay, if we are updating something, what is the value? How do we want to update it to? What do we want to update it to? And the last one is a flag. Is basically to specify to overwrite or not. Okay. In other words, if there's already a value, do we want to overwrite it? So we want to provide an option of no. If it's already there, just let it be. Okay. If it's not already there, create a new item with that value. So this way we have the option of whether to overwrite something or not to overwrite something. Okay. Now in the block here, this is kind of interesting because not too many blocks under control will fit this little notch here because it has to return a particular value. Several things will do. Okay, there's one thing under variable that will fit this bill. It is this one here. So we're going to have an initialize. We'll have local variables in this case. A local variable means whatever we define here as a variable is only visible within this block. Okay, it does not exist outside of this block. It is not accessible from outside of this block. Okay, so both the scope and the lifespan is just this block here. So we want to at least deal with a result here. The result is whatever we are going to return in the end, and we can initialize the result to a default value, and the default value has to be either a true or a false. So we can say by default the return value is true. Okay. Doesn't matter, it's just a matter of what we do inside the block. We can adjust accordingly. And then inside here we have the same problem. Once again we have the little notch here that has to provide a value. So what we'll do is we look under control, and there are several blocks that can fit this bill. Okay, there's the if then else that returns a value, and there's also the do result, which is what we want here. Okay, so the do result block has 2 notches, has 2 places where we have to insert something. The first one is, I would use the mouse pointer if I could, but if I use the mouse pointer, it pops up the text here, so that's why I'm going to use my finger here. So the first one, which is here, specifies a bunch of blocks as an operation. Okay, this is what we have to do as a bunch of blocks. And then the last one here has a little notch, and that one is going to be the actual value that we are returning. Okay, so in this case, the result here goes into the local variable block, which goes back into the result of the entire procedure. And we already know what the result is. It's just the local variable called result. Okay, so what we have to do here is to set result accordingly so that we end up with the correct result of the entire procedure. Okay. I'm not going to put in any extra error checking code here, so just to save time today and also save execution time, I'm going to assume this list is in fact a key value pair. It's not, the entire list is of that format. So if I can make that assumption, it makes things a whole lot easier, because the first thing I can do now is I'm going to change this to a false. Okay, I'm just looking a little bit ahead of time, and I'm changing it to a false. So what we'll do is we'll use a very convenient block to go through every single item in the list. Okay, this is a really useful particular control structure. It is not found in C, C++, or even Java, but it is found in a lot of other scripting languages like Perl, PHP, and so on. It gives you a control structure so that you can go through each item in a list. And so for each iteration, item is initialized to a particular item in the list itself. And the list that we are dealing with is KV list. So that means for each iteration, item is a list, but it is a key value list in that case. The first item is the key, the second item is the value. So now we can do some processing. The first thing we want to do is just to say, okay, are we dealing with the item that we are looking for? Okay, so we now look for string comparison or text comparison, and looking for equality, and say, is the key that we are searching for matching the first item of item itself? So now we go to lists again, and then we say select list item. The list is item because it is a key value pair. And then the index is going to be 1 because the first item of a list, of a key value list, is the key. So we are comparing the key that we are searching for with the key of the item in the KV list. Is that part okay? Because this gets a little messy, okay? It gets a little messy. If it does match, then we do something, okay? The first thing we do is we're going to set result to true to indicate, yep, found it. So we go to variables, and then we say set local variable result to true. Yep, yay, we found it. Now that we have found it, should we override it? Should we make changes to it? Well, we better make sure that we are supposed to, right? Because that's why we have this parameter, to override or not. So now we have to use another control block here and say, if we are going to overwrite the value, then we'll go ahead and do something. To overwrite a particular value turns out to be not too hard, because they actually ended up implemented this function correctly now. It was not correctly implemented before. But we can use this block here. Replace list item, which is exactly what we want to do. So the list that contains the item that we're replacing is not KV list, okay? That's the overall list. At this point, the list that we are dealing with is item here because it is a sub-list of the KV list. The index is going to be 2, which is the second item, which is the value. We are not changing the key, we are just changing the value, which is the second thing in that list. The replacement is the new value. Okay, so there we go. Are there any questions about this block of code here? No questions? Okay. I will definitely upload this file because I think this is a function that might be useful. Okay. Any questions at this point? No questions? Go ahead. Oh, row sheet. That's right. I keep forgetting it. All right. I'll start with here. Okay. All right. So this loop will automatically go through the entire list. It is not efficient because once we have found the value that we are changing, it will keep going even though the rest of the list is not supposed to contain the same key because it's a for each thing, right? Well, at this point, we are not too concerned about efficiency. We'll worry about it when the time when it happens. Okay, when the application gets too slow, then we'll say, okay, we'll go ahead and do something about it. But at this point, I'm not too concerned about efficiency. I'm more concerned about the correctness of the algorithm. And the simpler the algorithm, the easier it is to check that it is correct. So I would rather keep it simple than to make it fast at this point. Okay. After the for each list, I got something to do, because what if I go through the entire KV list and I still cannot find the key that I'm looking for? Okay, well that means I got something else to do. So we go to control here, and then we have another control if then block here, which is right after the loop. Now you have to see that the for each block is here, the if then block is after the for each block. Okay, it's not inside. So after, we have to say, what if the thing that I'm trying to find is not found? I'm going to append it, right? I'm going to create it at this point. So now we have to check the negation of result, because result is false to begin with. So it will remain false if I cannot find the item. So I go to logic and use the negation operator, and then grab result. So if not result, which basically means if not found, I'm going to append that new KV item at the end of the KV list. So that can be done with lists here. And we are just going to add items to list. Which list we're talking about? It's KV list, because item does not even exist at this point. We only got one list to deal with. And the item that we're adding is a new list. So we go to list again, and we make a list out of exactly 2 items, because the first one is the key, the second one is the value. The key is already one of the parameters, as is the value. So we are just using those 2 parameters to create a new list, which is the last item of KV list. And that should be it. That's the entire thing. Update KV list. It's now done. Okay. Now before I save this file, and replicate this screen several times, it really helps to test to see whether this works or not, right? Because if I don't test it, this may not work at all, and I end up with something that is replicated several times that has a bug. So when I have to fix it, I have to fix it multiple times too. So I better not do something like that. All right. So let's think of a way to test this using the least number of components. Okay, that seems like it's a good idea in the sense of we're not wasting a lot of resources to test it. It's a bad idea because I'm just abusing the components to no end here. Okay, so this is what I'm going to do. I go to designer. This is one good thing about using a wide view, is you guys can actually see the entire thing. I don't have to scroll back and forth all the time. So I go back to the designer view, and this is the main quote-unquote main screen. I drag one single button here, and go back to blocks, and I'm going to mess around with that button. So with button 1, I'm going to do something. I will go ahead and do the okay, so what I'll do is I'm going to create a local variable. Okay, so I don't even need a global in this case. So I have a local variable, and I'll just call that test KV list. Okay, because this is a KV list, but it's only for testing purposes. It starts its life as an empty list. Okay, so it has nothing in it whatsoever. And in this block here, I'm going to call this procedure several times. Now the problem with this procedure is the value needs to be consumed in some way. Okay, it just needs to be consumed. So there are several ways you can do this, depending on which way you think is easier. One thing you can do is to create another local variable, and we'll just call that dumpster. For obvious reasons, you will see why it's called dumpster. So that we can just whatever value we don't need to use, we'll just throw it into the dumpster. Okay, so now we can say set dumpster to, and then go back to procedures and use our brand spanking new procedure to deal with the KV list. So the KV list is test KV list, and we'll just go ahead and specify a key. I'll just say key 1. That's not what I want to do. I want to specify text. I just pressed the wrong key and deleted the whole block. Yeah, there's no undo. It happens. Okay, so let me see if I can do this. Text. There we go. So I just typed text on the keyboard and it popped up the box that let me choose. So I'll just say this is a key 1 for key value 1, and then I'll have v1 text first, and then specify text as v1 for value 1. No, it's too smart. Okay, and to overwrite or not, let's say true. Okay. So I'm going to test this one step at a time. So I'm going to only do this part here, and then I'll see whether it works or not. But Tab, you forgot the label. How do we know whether this list actually has the key value of K1 and V1? K1 being the key and V1 being the value. I'm going to cheat here. So the way I cheat is really bad. If you do this in any other classes as a homework assignment, you get into trouble. But for testing, it is okay. So I'm going to set the text of label 1 to be the output of the JSON version of the list that we're dealing with. I mean, it will do what is needed to test the software, but it is going to be a very obscure way to do it, because now the text that appears on the button is going to be some really obscure way to represent a list in JSON format. Okay, so let's go ahead and test it. So we'll go ahead and start up the emulator. I will definitely upload this one at the end of this class, because some of you might want to use this one too. If you have already started with your project, remember how to surgically transplant one procedure into it, so you can do that too. And there's actually a new, there's another match this weekend on Sunday, so I might be going to Concord.
How does rain affect that kind of competition?
Sorry?
How does rain affect that kind of competition?
Not at all. Rain or shine, because the shooting positions is covered. Now, one raindrop will definitely deflect a 7-grain little pellet to no end. It's like,
that's what I was.
But it won't affect just my pellets. The worst thing that can happen in a match is not just rain, but it's wind. On a windy day, it's bad. All right, so let's give it a test. Test text for button 1, click it, and I'm not really sure whether you can tell it's K1, V1 as a list inside another list, which is what it's supposed to be. But that's not the only thing I need to test, okay? We got to test it in some other ways, because I'm going to replicate this block here, duplicate, and put it here, because now I want to see whether I can actually overwrite something, because the first time I do it, it's not even there. I'm just creating a new key value pair and appending it to the end of an empty list. But this time I want to see if I can change the value from V1 to V2. Okay? Because this will test the second part to see whether it can do that. So let's go ahead and go back to the emulator and click the button again. And yes, it did update the value to V2. So I know I can create a new key value pair if I need to, and I can also overwrite a value when I need to. The third thing I'm going to test is to say, what if I say do not overwrite? Okay, does the logic not do the overwriting when it's not supposed to? So to test that, I'm going to change this one to false. So that means when I run the software again, it should retain the value of V1 and not update it to V2. So click that one, and it retains the old value of v1. So it is working, okay? It is working correctly. The only thing that I cannot really test, well, I suppose I can. The other thing I did not test is whether the return value is correct or not. It's supposed to return true if it finds it. It's supposed to return false if it cannot find it, right? That can still be tested given the context of this thing here. So instead of doing this, let's go ahead and disable this particular block. We'll add another one of set button1 text. I'll stash it here. And this time we'll take the return value and put it into the text of button1. So we can now, okay, can we just delete one block? This is dangerous because if it deletes the whole block, okay. Well, I'll give it a try. Yay, that worked. I pressed the delete key on the keyboard. All right, so let's go ahead and test the software again. The first time it should say false, okay? Because I have an empty list at this point. False, okay, that's good. Now we do it again and see if it will work. To be lazy, I can just, there are multiple ways to do this. I can go to button1, set the text, and this time to dumpster, because dumpster has the result of the previous call to update KV list. So now we say, okay, show me what is dumpster. And this time it should be true because K1 already exists. Okay, even though I'm not overwriting it, it should still be able to find it. So let's go ahead and check it in the emulator. And it says true. So I have tested multiple aspects of this particular procedure, and at this point I have not found any flaws with it. Which is not to say the procedure is flawless, okay? But I'm reasonably confident that it is working the way it's supposed to, okay? So this is now a good time to save the file again and download the version so that I have a local backup and then do the replication, because this is one screen that I don't want to use right away, okay? Because I want a template screen that remains pretty much empty, except it only has all the procedures that I want to have. Okay, so I can just replicate the screen to all of the other screens. Right, so we go back to my projects, make sure that is checked, and say export. Oh, why is it not letting me do it? Okay, there we go. Export selected project to my computer, and now we have this as open, it's parentheses 2. So I go through the same thing that we did last time. I can remove all of the other ones. So we can remove ftscorer.aia, remove ftscorer1.aia, and then rename the other one to ftscorer.aia, unzip it, ftscorer.aia. Oh, forgot to create a folder first. Okay. No, don't do anything. Let's make a new folder first. And this is also something that you have to do if you're planning to do any surgeries like this. So we cd ftscorer, unzip ftscorer.aia. Replace all, and then go to the folder where the screens are actually located, and we'll make a screen 3. So cp screen2.bky to screen3.bky. Screen 3. Okay, there we go. And then the second one has the extension of scm, which is also the file that I'm going to modify, because that also contains the name of the screen itself as a variable. And then the last one is Yale, and then I use a grep utility to find out who has the name of screen 1, and I think 2 of them now has screen 1. So I think all 3 scm files has it. So let's go ahead and update screen2.scm and screen3.scm. Oops, misspelled. Screen2, not screen2, screen2. Screen1, change to 2. Next one, change it to screen 3. That's it. All right. So now we go back up to the top folder, but not over the FT Scorer, and rezip it to the parent folder's FT Scorer.aia. Now, if you're careful and don't want to risk losing anything, you can use a new name. So you can basically just replicate a project. Every time you do this, you keep the original and you make the new one a separate project. So that way, if the surgery was not successful, you have the original to play with, which is what I'm doing here. And include everything here and specify -r for recursive. All right, so now we got this done. And I go back to AI2 and import the new file this time, which is FT Scorer 2. FT Scorer 2. So if the surgery was not successful, I am not losing anything because I still have my other one around. And let's double check. Okay, so screen 2 is here. Screen 3 should look exactly like screen 2. And it's there too. So the surgery was successful. So at some point I can start to delete the earlier versions of this project. But as long as I'm still kind of thinking, I don't know, maybe I still need it just in case something happens. Well, you know what? Just keep it around. Okay, it's not using up a lot of space. Cool. So what we now want to do is to say, okay, we got most of the utilitarian procedures that we need at this point. So it's time to actually design the screen to capture a single attempt, okay, a single shot, basically. Okay. So going back to the text file first, because remember we use a text file to represent everything here. There are several things that we need to have. The first one is the data structure for the attempt itself, and the second one is the configuration. So somebody needs to pass the configuration to me, or this screen can look it up in a TinyDB. So either way will work. Okay, so either if you pick it up from the TinyDB itself, or you can expect it to be passed by another screen. Which way do you think is better? TinyDB? It depends. It depends, because what if you have another application that you are writing that wants to utilize this particular screen of this particular application to capture one shot? Then it makes more sense to have it passed in as a start value, because the start value is a very quote-unquote universal way for applications to talk to each other. You can start one screen from within the same application from another screen, and you can use the start value to pass something. But you can also start an application using, what is the name of that thing? Application starter as a component. So if you use that other mechanism, it will still work. Okay? So using start value is a quote-unquote more universal way to pass information along, because it works from within the application. It also works across applications. Okay? So is it really worth the trouble to use it? I don't know. I mean, it's hard to say. But it's definitely one option. But you have the choice here. Okay? If you're writing your own application, you kind of have to gauge for yourself, which one do I want to use? Is it likely that I want to do this start this from another application? If the answer is no, well, you can go ahead and just use TinyDB in that case. Okay. So let's make that assumption, and we'll just go ahead and use TinyDB. I don't need button 1 anymore on my third screen. It's better to change the name first, just so that I know what screen I'm talking about here. So this is one single shot, or so I'll just call that in a particular attempt. So I just changed the label of the screen, so this way it's easy for me to remember what I'm dealing with here. And then we'll go ahead and get rid of the button. So we'll delete the button here. And I'll start with several things that I definitely want to use here. I started with a label, and this time I better rename the label because if there are multiple labels, and if I don't rename it, it's hard for me to keep track of which one is which one. This label reflects, which lane we're dealing with. Because this screen by itself is not the one to control which lane we're dealing with. This is only here to capture the result of a single shot, of a single attempt. So somebody else is going to keep track of which lane we're dealing with and which target we're dealing with. So we need another label to represent the target. So we use another label here and change the variable name itself first to represent this is which target we're dealing with. And then we can change the default text here to something else. So we can change the default text of the first one to actual lane number. So it is supposed to display the actual lane number. The second one is supposed to display the actual target number. Now the targets are not usually a number because each lane has two targets. So the way they classify the target is this the far target or is this the close target or near target? But I'll leave the labeling up to somebody else. Okay, somebody better pass the information to me to tell me which one it is. So after we identify the lane and the target, then we can go back to our text file and say, okay, what else do we need here? We need a timestamp, but the timestamp is not something that the user enters. Okay, it is something that is put into the log entry automatically, so it has no user interface. The other one is the distance, or the gauged distance, and also we have two buttons to represent hit or miss. And in this case, I just make it two individual buttons, so it's easier to see. Or we can use it a check mark. A check mark probably makes more sense in this case. So we have a gauge distance and a check mark to put into the screen here. For the gauge distance, there are many ways to do it. Using a slider is one way. Using a slider has the advantage of not having to use a tiny little keyboard to dial in to enter the actual number. Instead, you just kind of slide your finger to get to approximately the right value. And then we have one checkbox to represent whether it's a hit or not. So I'll go ahead and change all of these names because now they have actual meanings. So I'm going to change all of these names to represent to what they actually represent. So this is gauged distance, and checkbox 1 is checkbox hit. Okay. And we'll change the text to hit. Okay. And if you want to be clear, you can always say, target fell down, target fell. And then the slider needs to be modified to fill the parent container so that we have a wider slider as much as we can to dial in the number that we want. Are we doing okay so far with this application? I don't like it the way it is because, remember, this is in a situation where people have to enter all this information and not really have a place to really sit down and do all the fine motor control thing to get this all entered, which is kind of ironic because shooting field target requires a lot of fine motor skill, but the focus is on the shooting part. This part they don't want to spend too much time on to focus on. So we'll go ahead and do something to make this easier. Change the font size, okay? Make it bigger. So make it a 20-point font. So that makes it a lot easier to identify which lane are we talking about, which target are we talking about. And for the gauge, there's not much it can do here, okay? Unfortunately, because it does not allow you to change the height of the slider. For the text checkbox, we can change the font size at least. That is odd. it wrapped around. That probably has to do with not being quote-unquote automatic. Let's check it on the emulator and see what it looks like. It actually looks okay in the emulator. It's just that it doesn't show right, doesn't show correctly. Now the slider also needs its own label because the slider by itself does not show the value, so I'm going to have to use a label to show the actual distance. Okay, so this is the actual gauged distance, but as a text. And we'll change the font size to 20 and change the label to distance. Okay, but it will be replaced by an actual value with a unit. Okay. All right. So now we got all of this stuff here, and it's time to. We need one more button, which is to enter, the entry. Okay, to save the entry or to cancel and say, forget this. This is no good. Okay. So we'll go ahead and have one button to control the commitment. Okay. So we say save result. Okay. So name it, button, save, and change the text here to save. We can use another button for not saving the result and cancel, but pressing the back button usually does that also, so it's up to you to decide which way you want to do it. But I would just use save here and make the button also kind of extra bold, easier to click, so that people don't have to fiddle around too much, to save the button, to save it. Now, this is one thing that you might want to do. See how close the checkbox and the save button are located? It's easy to click one unintentionally, okay? Especially, when the intent is to click, this checkbox here, some people might accidentally click this button here. So you want to space them apart, and there's no easy way to do it, okay?
Layout works.
Huh?
Using a layout works.
Yeah, you have to use a trick to do it. Basically, you have to bring in something. It doesn't matter what it is. You can bring in an image that has actually no image in it, and you can change the height to say 200, and it will do it. It actually does not display anything. It's just using up space. But the whole intent is to separate the control unit here from the button that actually commits the values. Okay. So that's kind of important. Okay. I know this is not about this class is not about user interface design, but I have personally hit something like that more than once. Okay. So it becomes important to me to say, okay, let's make sure it's not easy to click something accidentally. So when you look at the layout, now the save button is all the way down here, which is a whole lot better than here. Okay, even though we have increased the text size and whatnot, it's still easy to hit the wrong button. All right, great. So we got almost everything done as far as the screen layout is concerned. And now we have several other things that we have to do. The first thing we need to do when this screen is first loaded is to figure out, okay, what is the unit of the distance here? Because that's the first thing I need to know is how to do the conversion. Is that making any sense? And we can go ahead and just assume that's in the TinyDB. All right? So what I'll do is I'm going to use a procedure for initialization. So this way I can trigger the logic from anywhere within this screen and not necessarily only from initialize. I know for sure that when this screen is initialized, I got something to do, but I'm not going to put that logic here. I'll put it into a procedure. So now I use a new procedure to basically capture what to do when I need to initialize this particular screen. And I'll make it very clear, initialize screen. There we go. All right. So the first thing we want to do is to read it from the TinyDB. Okay, what is my measuring unit? So let's go ahead and do it. So we go, I don't have a TinyDB yet. So let's go back to Designer, go to Storage, drag and drop a TinyDB. Then we have to go back to blocks and use it. Now, when you are using TinyDB, now you also have an option. Do you want to have one key in TinyDB for distance, another key for something else, and so on? Or do you only want to have one single list for the entire configuration? Okay, I cannot decide for you. Okay, this is my application. I will choose it one way. But if it's your application, your project, you have to choose. I would say if there is a need to send the entire configuration to someone else, to another screen, to another application, use a single list. Okay, use a KV key value list to do it, because then it's easy to encode the entire thing. It's already there. Okay, if it's only a few things and you think only this particular screen needs these things, then you can just go ahead and use the key itself in TinyDB itself. Okay, but personally, I like to use a key value list. So what I will do, I picked the wrong type of procedure. This one does not need to return a result, so I'm going to use this one instead. So initialize screen. And what I would do now is to go to TinyDB and say I want to get a value based on a tag. And make it my global variable, which is my configuration. So I need to go to variables, initialize global variable, config to an empty list initially. So create empty list. So that in initialize screen, I would go to variables and use the set block to read the configuration back from the TinyDB. The tricky part is this value. I don't want it to be a text string when nothing is found. I want it to be an empty list when nothing is found. So I would put an empty list here. Is that okay? And the tag is entirely up to me to decide, how I want to name this tag. What I want to do is to make it consistent with the name config here. So I'm going to pick text and just say this is my config. Okay. Now, if I really want to be anal and make sure that everything is consistent, I would do something like this. I would go to variables again and config string and change this one to config here, and then over here I would use my global variable config string. Now, doing this seems to be totally unnecessary. Okay, it seems to be a step that is both unnecessary and just kind of, why do we want to do something like that? Well, if this screen has any ability to save back into TinyDB, I will have to re-specify the key, right? Because every time you read from TinyDB and every time that you write to TinyDB, you have to specify the key. So what are you going to do when you specify the key if you do not have a global variable that only says config? Well, you spell out config again as its own text. What if you spell it out wrong? Do you see what I mean? What if you use lowercase config when you're reading from TinyDB and you use uppercase C config when you're saving it? Then it has two entries, right? Whatever you're saving is not overwriting whatever you were reading when it starts. So the symptom would be as if it's not saving correctly. But the reality is it is saving correctly, but to the wrong key. Doing it this way means if I use the global variable config string consistently, I can never make that mistake. I can misspell config as CNFIG, but it will be consistent. Okay? So I cannot have problems like that. So by doing this kind of thing, I'm saving myself a lot of trouble down the line, even though at this point it seems like, what a waste of time. This is something that we don't have to do. Well, it is useful down the line. We are kind of running out of time today, so I can give you a preview of what else we need to do next Monday. So on next Monday, what I'm going to do is I will flesh out the content of initialize screen. Because what if there's no configuration yet? Well, then I better make sure that there is some kind of configuration. So I'm going to specify the default values of distance unit and a few other things, and save it back into TinyDB1. So that way, if it is not there already, I would have a default value and it will be saved into TinyDB. Okay, so that's what we'll do next Monday. And I'm hoping that at this point, this is already starting to help a little bit of your project, how to structure it. You might have to do some transplanting, one procedure into your into your project and whatnot. But that's what we need to do for this class anyway. So the class is over, because we are running out of time. And I'm going to upload this file, just so that you guys have access to it too. I'll see you guys on next Monday. Have fun with your project. I'm really hoping that you guys are having fun because that's what it's supposed to be.
It's a good blend of